Hi guys, Buildzoid here, and it has been, it what to me feels like ages since we've had a interesting GPU PCB to look at. Is that the right color? Yeah, that's the right color. Cool. So this right here is a 5700 XT Strix from Asus, of course. And the picture is from Tech Power Up, so huge thanks to Tech Power Up for, providing such high resolution PCB shots. And also, like, they also make it really easy for me because they also do close-ups of all of the components these days. So, life is really easy because they already do a good chunk of what I normally spend a lot of time doing for me. So huge thanks to them for providing the pictures. Now then, yeah, this is a 5700 XT Strix, and this is probably going to be the best 5700 XT PCB that you can get. Now, admittedly, the Strix cards, especially these days, tend to command a pretty large premium compared to other models from other manufacturers, but I'd say, I'd consider that justifiable with, like Asus, the thing is, a lot of other board GPU makers, they'll throw together a PCB that's, like, slightly modified versions of the reference card, or something that's actually very different, but still roughly in the same sort of performance category as the reference card. And then there's Asus, who give you a 5700 XT that looks like this, and I love it. Like, I absolutely love it. And the thing is, they also include a bunch of sort of, like, extreme overclocking features, that I think are pretty neat. So we have, I do believe the O point, the O stands for over voltage. And so I'm not 100% sure about what the names are, but I'm going to say overvolt SoC, overvolt IO, overvolt GPU, overvolt memory. So the IO would be that'd be like the VDDCI. Actually, yeah, that'd be the VDDCI rail. So yeah, there's your I. And then you have the SoC rail, which is a new rail introduced with, I want to say the big Vega had an SoC rail as well, and maybe even the older Vegas had an SoC rail. I'm not sure right now, but either way, that's a new rail. Then of course we have the GDDR6 rail, so we have overvoltage points here. I'm not sure how those actually work. Unfortunately, Asus hasn't been, like, in the past, they'd put out really detailed overclocking guides where they'd explain how to use all of these overvoltage points. And I assume these points right here are just monitoring, because the overvoltage points, you're probably just going to be pulling them to ground through some kind of resistor to get your overvoltage, because I'm 99% sure that these are just feedback mods. But anyway, there's a set of, like, this pad right here, which you would have to short out to enable all of this, I think. And yeah, this is really cool. Like, if they actually release a just, hey, this is how you use this to break your card, I'd be a huge fan of that. The thing is also, like, they have this pad right here, which makes sure that you can't really, you can't make use of this without making it really obvious that you voided your warranty, because these come untinned. So if you ever solder on them, like, I don't know how you'd actually get the tin off of them afterwards. So yeah, good luck with that. Anyway, we have an LED on-off button and a dual BIOS switch, which is pretty cool. If you want to mess around with BIOS flashing, then Asus has you covered. You're not going to end up with breaking your card, though it is worth noting that I'm pretty sure on Navi you can't do anything to the BIOS, so that kind of useless. But they do have the card ships with a quiet BIOS and, like, a normal performance BIOS. Actually, it's a performance BIOS. Yeah, that's what the P is. So basically, the quiet BIOS, lower fan speeds, more quieter, worse temperatures. Performance BIOS, I think performance BIOS doesn't have, like, a fan stop at idle and ramps up the fans harder. So I'm not sure if there's any other differences between the two BIOSes. There might also be, like, power limit differences, but yeah. Anyway, so already you get a little bit more than you'd get on any other card. Another thing that I'm a huge fan of is they have an actual header. Like, well, it's unoccupied, but you could very easily throw on a header for the I2C interface of the voltage controllers on the actual card, which, basically, if you're going to use something like, say, an Elmore EVC or an Infineon USB 005, this is super handy, because it should make it really easy to control the voltage regulators on this card. So honestly, like right now, if Asus puts out a 5700 with this PCB, I might just get that, because I really want to get the pin out for the 352217, and the easiest way to get that is just through this. Plus, it would be just much more convenient to work on a card that has this integrated into it compared to some of the other cards, because I do have a USB 005, and it's just like I haven't been able to use it on Vega yet. Anyway, so that's pretty cool. And then, of course, they have LED indicators for if you've plugged in your power connectors. So, yeah, which isn't really that useful, but it's there if you care about that. And then on the front side of the card, what do we get? Well, we get a bunch of fan headers, I think an RGB header, and then these, which I don't know what I think probably just more RGB, isn't it? It's probably what that is. So, yeah. Oh, wait, no. That's the I2C, isn't it? Yeah, that should be it. Not this one. Okay. Anyway, the one nearest to the controller, that's probably it. I mean, if you have the card, you can check. So that's pretty cool. And on the reference cards, you don't get that connector, which just makes it much more annoying if you want to do, manual control of the controllers through a actual like control dongle, like an EVC2 or a USB 005, because the USB, like this is I'm not sure if it supports the 35217, but it does support this chip right here, which is a 3567, and I'd assume the 35217 would be supported because that's a current generation Infineon controller, and the USB 005 is like the most recent dongle they have for all of their stuff. So anyway, so that right there is an IR3567B. And at this point, we're going to start getting into the VRM. Now, unfortunately, I'm not sure where everything is. So, like the SoC rail and the I/O rail, I don't know where they are. So, IR35217. But they're, like, I have a rough idea of which one, like, which phases are the SoC and I/O, but I'm not sure which, like, for sure which one's where. So, anyway, there's your 35217. And the Vcore VRM is, of course, the largest VRM on the entire card. And for some reason, I included the capacitors, which I don't normally do, for the simple reason that it's impossible to include all of them. So, yeah. So there's your Vcore. Then below that, I assume we have SSOC. So I think this is VSOC. And I think it's VSOC because I think the SoC has to be on the 35217, but I'm not 100% certain about that. Then on the other side of the card, we have these three phases right here, which are split right there. And the top part is VMEM, and the bottom part is probably VDDCI. So that's your memory controller rail. So that's sort of that's the voltage regulator layout. Let's get into the details of Vcore. So Vcore here is it's just a 5-phase. I know it looks like a 10, but it is very much just a 5-phase because Asus is doing the thing where they put 2 power stages and 2 inductors onto 1 PWM signal, which sort of like, it has its advantages, it has its disadvantages, but honestly, like if you're doing it with like the thing is, if you're doing it with really high-end power stages well, yeah, that's pretty much it. If you're doing it with really high, like the VRM ends up like it's a cheaper way to build a really powerful VRM, slightly cheaper, but yeah, if it's really, really powerful, then like why would I, like, I'm not going to complain about it. Also, it just means that basically the main downsides to not using doublers is that you'd have more input ripple, more output ripple, and the problem with that is, well, the thing is, you can just fix that with a better, configuration of output filtering capacitors and input filtering capacitors as well. So, there's no, like, you have to have this many phases. It's just that in most scenarios, it's easy. Like, there's certain things that are better if you have more phases and certain things that are worse if you use doublers, which is primarily transient response. So, yeah, I don't see a problem with building a 5-phase like this because it's one hell of a 5-phase. Like, yeah, this is straight up the most powerful 5-phase I think I've ever seen. Yeah, ever. Literally the most powerful 5-phase ever that I've seen so far. So the power stages used here are a TDA two 1462s, and these are 60 amp smart power stages from Infineon, and these are insanely efficient. Like, they are basically, the efficiency curve for these is basically the same as the efficiency curve for the 70 amp smart power stages from Infineon. It's just like slightly worse. So I'm not entirely certain what it is that makes these a 60 amp part compared to the TDA21472s, because if you just look at the heat output across, if you just compare the heat outputs between the two, it's basically the same, especially at lower current outputs. So yeah, like the end result is that this VRM, because it has 10 60 amp smart power stages, is way overkill. Well, nah, it's not necessarily way overkill, but it's really, really nice, and far nicer than what you're going to get on any Navi that's sort of reference design based. Because the reference design uses a bunch of FDMF 3170s, and it's only 6 of them. So this basically has a quantity advantage, and these are slightly more efficient than FDMF 3170s. So yeah, they're also more expensive than 3170s, but I assume Asus is already using them on multiple other designs, so they just have a stockpile of them already, and it's just like, well, just keep using them. So the end result is that, so, you know, the 35217 is running 5+1 phase mode, because the +1 is, of course, the SoC rail down here, and that's another TDA21462. So that right there is super overkill. But anyway, let's talk efficiency for the Vcore. So outputting 1.2 volts, which is more than what Navi runs on, 400 kilohertz switching frequency, and 5 volts drive. You're going to be seeing the following sort of heat output, well, following efficiency from this VRM. So 150 amps output. This VRM will produce probably around 11 watts of heat, which is nothing. Like, that is absolutely nothing. You would, like, if you ran this card with just a core-only water block, you wouldn't have to do anything about the VRM cooling. That is not a significant amount of heat whatsoever, especially considering that it's spread across this much surface area, right? Like, the VRM itself has a certain amount of surface area. For 11 watts of heat, this is more than enough. Going up to 200 amps, you're going to be seeing about 16 watts of heat, which might still be doable if it's like no heatsink and just some airflow, but you'd probably start wanting a heatsink at this point. 250 amps, this VRM will produce about 21 watts of heat, so definitely want a heatsink at this point. 300 amps, you're going to be looking at about 27 watts of heat. 350 amps, I'm not sure where Navi tops out. I've not really bothered, like, I've not worked with one of them at all, so I've just kind of gone through and every 50 amps up until 400. So 33 watts of heat at 350 amps. So, like, the efficiency here is just insane. Like, the efficiency doesn't drop below sort of 90%. Well, actually, I don't think it ever goes below 90% in the entire current rating range that I bothered to go with. So, yeah, like, this VRM is awesome. Anyway, 400 amps output, you're going to be looking at about 40 watts of heat, and 500 amps output, about 60 watts of heat. So, yeah, this VRM is crazy efficient. And, you know, if I wanted to choose a Navi to go do, like, extreme overclocking or anything, I'd choose this one. Like, I would literally just go for this one. And honestly, depending on the price, I'd probably get this one even for my daily. Just because the VRM is so much better than what you're going to get on pretty much. Like, I would be very surprised if there's any card that comes even close to this one in terms of VRM configuration. So, yeah, like, Asus still makes some of the most, you know, some of the best custom PCB GPUs out there. Right, the 2080 Ti Strix is basically my favorite card outside of the Hall of Fame and the Kingpin edition. And then I haven't really looked at the rest of it. Well, no, I remember looking at, I think, like a 1660 Ti from Asus, and it was also like insane overkill for what it for a 1660 Ti. So, yeah, this thing is awesome. Like, this is a really, really nice PCB. And yeah, the Vcore VRM is absolutely massive overkill. And And like it's just straight up like the thing is the reference card, right? It uses six phases of 70 amp power stages. So the reference card has an absolute maximum rating of like 420 amps. And at 400 amps, this VRM, like, yeah, 40 watts is hot, but as long as you have a substantial heatsink on it and some airflow forced into that heatsink, this is doable. This is completely doable. Whereas on the reference card, no matter how much heatsink, like on the reference card at 420 amps, you'd probably be looking at around 80 watts of heat output, somewhere around there. And well, it would need significantly more cooling. Also, it's small, it's more, less surface area, more compact VRM, so it would just run, like, you'd need more cooling just because it's smaller. So, yeah, that VRM, just compared to this, it doesn't compare. Right? Like, this is so much better. So, yeah, I'm a huge fan of what Asus did here with their VRM. For the Vcore, for the SoC, I mean, like on the reference Navi, you just get a single phase for all of the minor rails. So, SoC here, a single phase. Just for like, I'm not sure how much power the SoC rail has to deliver, but it should be less than 15 amps. So, for 1.2 volts, for like all of the same, these settings, right? This VRM would do 15 amps at about 1.1 watts of heat, right? There's your difference, right? So 1.1 watts of heat for SoC. VDDCI, again, I don't know how much this rail pushes in terms of current, but it's another TDA21462, so more of that. And again, like, even if it was doing, like, the thing is, if this is 15 amps, right, and this is also 15 amps, and then you have the memory rail, which is, let's say, another 15 amps, that's 45, like, basically, I'm not sure how much power the memory system on one of these pulls, but I don't think it's 15 amps per like rail, or like it should be less than that. And yeah, so I just kind of went with like, okay, 15 amps, 1.1 volts, 1.1 watts again for this one. So, this probably doesn't even need a heatsink. And then VMEM, we're looking at two phases of yet more. So the 3567B is running in 2+1 configuration. And the VMEM is, more TDA21462s. So even if this was pushing as much as 30 amps, you would be looking at only 2.2 watts of heat. So yeah, like this card is just like, it's great. It's absolutely awesome. We also have a bunch of minor voltage regulators scattered around the card. I'm not sure which one's which. I assume this right here is 5 volts, because you do need the 5 volts drive rail for the power stages. So I assume that's a 5 volts linear regulator right there. But then we also have things like this right here and that right there. And I assume like these are going to be like PEX, zero, like you're going to have the PCIe rail. You're going to have the display drive rail. There's probably a 1.8 volts rail, which might be this. Like, I'm not sure which ones are what exactly, but yeah, because there's just a bunch of minor rails just scattered around the card. But yeah, like for the main ones, Asus straight up gives you voltage control points, and they're awesome. Like, they're really, really powerful. And the minor rails, I don't really pay that much attention to them because they don't really deserve that much attention. Like, obviously, if you don't have them, the card won't run, but they don't really push any a significant amount of power, and their power consumption doesn't really change with overclocking, so you don't have to worry about them. So, yeah. Anyway, so that's kind of that for the card. This turns out that this is actually rather short, isn't it? So, yeah, Asus also, like, well, I didn't really look at too much detail, but it looks like I think Asus upgraded the output filtering just everywhere. Now, I'm personally not a fan of cylindrical aluminum polymers. Also, I can't identify who, like, I have no idea who makes these. So that kind of sucks. But the thing is, I'm not a fan of, cylindrical polymers because basically, compared to the SMD type, so these guys, you have more ESR, more ESL, and that just makes them worse at suppressing, well, just makes them worse at doing capacitor things in your VRM. But the thing is, Asus is also mixing in a lot of multi-layer ceramics in between that, so yeah, I like the thing is, it's like, why did, like, they could have populated some of these. I feel like they should have just populated some of those, and then it would be like all like way just in general way better than the reference card. But still, that would have probably been just totally unnecessary amounts of overkill. But yeah, like I really like this card. Like from a power delivery perspective, it looks great. From sort of voltage regulation, I assume it's at least on par with the reference card, if not better. And well, the thing is, these just have more capacitance than SMD polymers, so like you do have an advantage for like load release and like for slower transients. These actually have an advantage. It's just that at really high, like if you have some really high speed noise that you need to deal with, these are completely useless because they're just too high ESR and too high ESL to deal with that. Anyway, yeah. So that's the 5700 XT Strix. It's great. Like honestly, it's really really great. I'm happy that's like the thing is Asus has like they've had a few blunders with their sort of custom PCB cards, but it's never really like I can't think of one card where it's like, oh, this PCB was like really bad. It's just like sometimes they make a PCB that's just like on par with what you would get reference in some cases. But this thing just blows the reference cards away. And I would not be surprised if, you know, this was just straight up the best 5700 XT PCB you could buy. Because I can't see anybody else putting this much effort into it. Which is kind of a shame. But it also makes sense is like AMD cards just don't sell that much. So I'm kind of surprised that Asus goes so far. Like they really go out of their way to do this. Because all the other board partners, they're just going to, probably most of them are just going to take a reference card and then just smack a bigger heatsink on it and go like, there's our partner card. We're done. We're not changing anything else. So, yeah. You know, if you want sort of the best 5700 XT PCB, you're looking at it. It's this one. And that's kind of it. So thank you to Tech Power Up for providing for having these pictures up on their website for people to use. Huge thanks to them. There's going to be a link to their full review of the card down in the description. And that's it for the video. So thanks for watching. Like, share, subscribe. Leave any comments, questions, suggestions down in the comment section below. And if you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description. And I also have, there's also a Teespring with sort of AHOC merch. So stickers, shirts, posters, hoodies, that kind of thing. If you'd like to buy anything like that, there's a link to that down in the description as well. That's it for the video. So thanks for watching and goodbye.